Frames or reference. Objectives. Identify and describe motion relative to different frames of reference. Calculate the one-dimensional velocity of an object in a moving frame of reference. Assessment. A train is moving directly away from you at a speed of 20 meters per second. Someone on the back of the train throws a ball directly toward you at 20 meters per second relative to the train. Draw a sketch representing the scenario labeling the velocities. Describe the motion of the ball relative to you. Physics terms. Reference frame, inertial reference frame. Equations. The velocity in reference frame 2 equals the velocity in reference frame 1 plus the velocity of reference frame 1 relatively to reference frame 2. What is frame of a reference? Imagine you are on a moving train. You choose a dart towards the rear of the car past a friend who is also on the same train. What is the speed of the dart? What is a frame of reference? That depends on who is asking. The train is one reference frame. The friend on the train measures 10 meters per second in the reference frame of the train. What is a frame of reference? A reference frame is like an imaginary box that you choose to be at rest for the purpose of making measurements. The train car is a reference frame. What if the reference frame is moving? The train is moving at 10 meters per second with respect to the ground. The ground observer sees the dart move 20 meters in 1 second. 10 meters forward on the train plus 10 meters that the train itself moves forward. The idea for reference frames. Velocities appear different to observers in different reference frames. The velocity of the dart relative to reference frame 2 is v2. The velocity in reference frame 2 is the velocity in reference frame 1 plus the velocity of frame 1 with respect to frame 2.
Two cars are moving toward each other at 20 meters per second relative to the ground. What is the speed of one car relative to the other car? In 1 second, the cars get 20 plus 20 equals to 40 meters closer together. Therefore, they approach each other at 40 meters per second. Using reference frames, let the road be reference frame 1. Let the right-hand car be reference frame 2. The driver of car 2 is at rest in this reference frame. Reference frame 2. The road, reference frame 1, is approaching the driver of car 2 at 20 meters per second. Car 1 is approaching the driver of car 2 at 40 meters per second. Therefore, the speed of car 1 is 40 meters per second in reference frame 2. Test your knowledge. An escalator moves downward at a speed of 3 meters per second. A shopper who can run 5 meters per second decides to run up the down escalator. What is the shopper's speed with respect to the mall? The answer is plus 2 meters per second. In the shopper's reference frame, she is at rest and the mall is moving. What is the velocity of the mall in her reference frame? The answer is minus 2 meters per second. All motion is relative. In the reference frame of your classroom, a chair at rest has a velocity of 0. In the reference frame of the solar system, the chair has a velocity of around 30,000 meters per second. Inertial frames. An inertial frame is a reference frame which has constant velocity. The laws of physics are equally true and useful in any inertial reference frame.
Physics in inertial frame. Your classroom on Earth is approximately an inertial frame because Earth's orbital speed is constant. However, Earth's rotation and orbital motion cause its velocity vector to keep changing direction. This effect can be detected in careful experiment. Switching reference frame can be very helpful. It can reveal a simpler way to solve a problem. Here an example. Physics in inertial frame. Imagine you are on an airplane. The plane keeps a constant speed and altitude. It is huge, windowless, and soundproofed. How can you tell that you are moving? Drop a ball. Weigh yourself. Is there any experiment you can do that will tell you that you are moving relative to the Earth? No. The only way to determine the relative velocity of a reference frame is to look outside the reference frame and make measurement relative to some other reference frame. Relativity. Everything we have said about relativity velocity applies to ordinary speeds. But when velocity approaches the speed of light, strange things happen. Time can pass more slowly. Stop in a moving reference frame as observed from a stationary reference frame. This is due to the effect of special relativity. Assessment. A train is moving directly away from you at a speed of 20 meters per second. Someone on the back of the train throws a ball directly toward you at 20 meters per second relative to the train. Draw a sketch representing this scenario. Labeling the velocities. Describe the motion of the ball relative to you. The ball does not move toward you at all. It drops straight to the ground because its horizontal velocity is zero in your frame of reference.